Fission. In chemistry, fission is the splitting of an atom or molecule, particularly related to covalent bonds. We have homolytic fission, where each one will end up the same, or heterolytic, where each one will end up different. If you think about it, homo means the same. So, in homolytic fission, we're going to start by looking at an atom of chlorine. If we remember, we draw a dot and cross diagram. Chlorine having 7 electrons in the outer shell, just needs one paired with another chlorine atom to make a chlorine molecule. One covalent bond just being the shared pair of electrons. So, with the dot and cross diagram finished there, homolytic fission happens when UV light, its incident, hits a chlorine molecule and will split it apart homolytically, meaning that you'll end up with 2 products exactly the same. So each chlorine atom will take back its 1 electron from the covalent bond. Once again, as you see the crosses appearing, you'll see that chlorine has 7 electrons in its outer shell on both sides. So although this is a neutral atom, with the 1 unpaired electron, it does make this chlorine very reactive. These reactive ones we call free radicals. So, on to heterolytic fission. Hetero means different. Edward Cullen, he's different and most likely hetero. But on to the process of fission itself. If we take a molecule of bromine, heterolytic fission will occur. We'll need something to push the electrons to one side. Because as I've already said, heterolytic fission is going to end up with 2 different products. We'll come back to exactly what can push electrons around in a molecule in a different tutorial. But as we can see, dot and cross diagram almost finished. 7 electrons in the outer shell again, 1 pair of shared electrons for the covalent bonds. During heterolytic fission, all of the electrons from the bond are going to be pushed over to one side. So one product will have an extra electron, which it gained from the other atom. And the second product will have 1 less electron, having been taken away by the other bromine atom. Okay, so when that finishes, you will see it comes up, they are charged atoms. Strangely, one of them will be positive. We will make a Br plus ion. It's quite rare. It doesn't have a full outer shell. Again, it's going to be quite reactive. The second one will be more of the normal bromide ion that we're used to with a full shell. Hope you enjoyed the first tutorial I made. I'll make many more of them in the future.